Hello everyone. In this video I am going to demonstrate FSK or frequency shift keying based data transfer on a power line. As you can see, this is my setup. So here in this setup you can see this is the transmitter part and this is the receiver part. This module and this Arduino is the receiver part. So here you can see the transmitter is sending data at a rate of 300 baud, 300 bits per second to the modulator unit. The modulator unit, let's take a very close look of the modulator unit. You can see data is coming to the modulator unit. It is optically isolated and it is modulated using the 555 timer IC. It is the FSK modulator, frequency shift keying modulator. This modulator generates two different frequencies, F1 and F2. The output of this modulator comes from pin number 3 of 555 timer IC and it is fed to this power MOSFET. This is IRF 840 power MOSFET. This power MOSFET is driving this transformer. So this transformer is basically coupling the data, transmitted data to the power line. So currently the power line is not connected. So this transformer is connected directly to the secondary receiving transformer. You can see this transformer is directly connected to the secondary receiving transformer. I will show the circuit diagram, then this wiring will be very clear. The output of this secondary transformer is fed to this envelope detector. You can see here, this is the Schottky rectifier, high frequency rectifier, and here is the capacitor and the resistor network. After the demodulation, the data is fed to this comparator. You can see here LM339 comparator is there. So one pin of the comparator is fed with fixed voltage, fixed DC voltage, and the output of the envelope detector is compared against that fixed DC voltage, and here we are getting a plus 5 volts DC output for the Arduino Uno analysis. So output of this LM339 is finally fed to this Arduino Uno. This is the receiver Arduino Uno and the received data is shown in the console. So this is the far view of the circuit, you can see. So I am going to explain the circuit diagram first, then I will show you the waveforms and the data received. So as you can see here, this is the circuit diagram of the transmitter. So the transmitter part is connected. You can see here this data is coming from Arduino Uno. You can see this plus 5 volt is also coming from Arduino Uno. This is the indication LED and here is the optocoupler. So this optocoupler is basically isolating the Arduino Uno to the modulator. So output of this optocoupler is fed to this transistor SL100. You can see here, and this SL100 is connected to pin number 7 of the 555 timer IC connected in stable multivibrator mode. So here it is switching between two frequencies F1 and F2. The output of the 555 timer is fed to this power MOSFET and finally it is fed to this power transformer. You can see there are 3 windings in this transformer. They are all similar windings, 12 turns windings. So one winding is kept spare. This winding is kept spare because later on I would plan to make modulator demodulator unit as a single unit. So if I am making a single unit, I need to have a demodulator also here. So this winding is kept as a spare winding. Currently it is not in use. So you can see here the output of this winding. You can see this winding, one winding is spare. This is the transmitter main winding and this is the power line coupling winding. So this coupling winding is connected here to another transformer. Currently I have not connected the power line. The power line will be connected in series. So here you can see there is no power line connection. So the output of this transformer is fed to this transformer again. You can see. Let us look into the circuit. Let us look into the project, how it is done. So this is the transmitter transformer and this is the receiver transformer. So output of this one winding of the receiver transformer is fed to this envelope detector. Output of the envelope detector is fed to this comparator. I am comparing it with plus 5 volts DC supply set at 3.07 volts. Here this voltage is 3.07 and here this voltage is 7.94. This voltage is pretty high because it is the main power line and it is, you can see here, this is a 12 volt supply line. So here the voltage will be definitely high. So you can see there is a comparator comparing the voltages and finally it is getting plus 5 volts DC voltage with data. So this data is fed to Arduino Uno. Let us look into the waveforms first. As you can see, this is the waveform. This is the waveform at the receiver Arduino, and this is the waveform at the transmitter Arduino. You can see both the waveforms are exactly identical. Here you can see there is another set of data. This waveform is at the input to the envelope detector, and this waveform is the final output waveform. Let us zoom this waveform. You can see upon zooming how is the data. Let us zoom it further. You can see here high frequency components are present inside, and this is the data after the comparator. Let us look into the data console. You can see at the receiver Arduino, we are receiving alphabet M continuously. You can see the transmitter is sending alphabet M. Here also we can receiving alphabet M continuously. The data rate is 300 baud. So as you can see here, the real power line is not connected. This is just a test circuit prior to the connection of the power line. So in the next video, I am going to connect the power line and we will be seeing the performance of this circuit. Thanks a lot. Thanks for watching.